All right, so now we're starting our probability unit. So first we're going to take a look at defining a few terms. Probability is the ratio, remember ratio is a comparison of two numbers, of favorable outcomes in an event to the total number of outcomes. So what I typically do when I set up probability is I give my answer as a fraction. So let's think about the event of flipping a coin. If you're wondering what the probability of flipping heads is, this would be the theoretical probability. You should get heads 1 out of every 2 flips. So the favorable would be how many times you'd flip heads, and then total outcomes, there's 2 possibilities. Experimental probability is what actually happens. So let's say you flip a coin 50 times, so that was your total number of outcomes. And of those 50 times, 20 of the times that you flipped the coin, you got heads. So the experimental probability isn't exactly matching our theoretical probability. All probability is a number between 0 and 1. A probability of 0 means the event is impossible. So for example, if you roll a die, what's the probability that you roll a 7? That would be 0. It's impossible to roll a 7 when you roll a die. Through 1, or if you're giving your probability as a percent, it would be from 0 to 100%. And a probability of 1 would mean that it absolutely has to happen. So you could think about the probability that when you roll a die, it's a number less than 7. That would be 100%. So we're just going to take a look at calculating some simple probability for today. So our first example is Johnny just throws his socks in the drawer. He's got 12 white socks, 8 black socks, and 6 navy socks. So what is the probability that Johnny randomly grabs a white sock out of his drawer without looking? Well, the number of favorable outcomes would be 12 because he has 12 white socks in his drawer. And the total number of possibilities would be all of his socks. So 12 plus 8 is 20, plus 6 is 26. And whenever we give our answer as a fraction, we simplify it. So these both have a common factor of 2. Dividing them each by 2, I get a probability of 6/13. For B, we're noticing that we've got the probability that he pulls a black or a navy sock out. Well, he has a total of 14 black or navy socks out of 26 socks in his drawer. Again, it's simplifying, dividing each by 2, I get 7/13 for my probability. And my last question is the probability he gets navy or white. Well, he has a total of 12 plus 6 or 18 navy or white socks out of the 26 socks in his drawer, gives us a probability of 9/13. Next, we're going to take a look at this spinner. So what is the probability that if we spin the spinner, it lands on an even number? Well, we have 2, 4, 6, and 8 were 4 even numbers out of 8 numbers on the spinner, which would simplify to 1/2. What's the probability that we land in a red section of the spinner? There are 2 red sections out of 8 sections total, which would simplify to 1/4. This last one, what's the probability that we land in an odd space or an orange space? So when we're looking at this, I see 4 odd spaces and 2 orange spaces. But one of the spaces is odd and orange, so we can't count that twice. So we could just go around. Let's count. We've got section 1 is odd. So there's 1, 2, the marker's not showing up here, 2, 3, 4, 5 sections that are odd or orange. So we could just say 5 out of 8 to make sure we don't double count that 7. And our last slide is looking at a table to calculate probability. So our first question is, if we were going to randomly choose a person, what's the probability that one of these people would be a boy or a senior? So this is similar to that last example where there's people that are boys and seniors, so we're not going to count them twice. So what I'm going to do for this probability is count all of the boys, and then I'm just missing the senior girls. So I'm going to add up all of those numbers, and that gives me a total of 166 people out of, and then I'm gonna add up all of the numbers on the board, 257. So I have a probability of randomly choosing a boy or a senior to be 166 out of 257. So I'm gonna go ahead and erase this now. All right, let's take a look at our next probability. What's the probability that we randomly choose a freshman? Well, there would be a total of 57 freshmen out of, and I already calculated the total, 257 people. And then our last probability, what's the probability we get a sophomore or a junior? So in this case, there aren't any overlaps. There are no people that are sophomores and juniors. So we're just gonna count all of the sophomores and all of the juniors. And that would give me a total of 130 people out of 257.